Here's the term project for electronics. This week I'm doing part 1, so that's this portion of it. Okay, and here is the circuit in action. Got hooked up to power, and instead of the light sensor, we have a resistance box here. According to these calculations here, let's see if we can get it focused. It should switch at 1K and 4K. Okay, here's the simulation for the circuit. Starting, let's see here, on the first situation. We're representing the light sensor with this resistor here. So this is when it's set at 900, which should be about 110 lux, outside of our range of what we want. Our output is the current here at this point, and it should be 0 in this case, and it is. This is a min function. This has the lowest value, basically 0. So that's the only diode that's turned on. These are not turned on, so the output should be basically 0 amps. Here's the second situation. This is just dropping below that 100 lux, so we're inside of our range for having output, and that happens according to the min function. Both of these should be off. Both of these should be on, and current going out should be about 400 microamps is what we're aiming for, and this gets close. It gets 480 microamps. Moving to the next, we have 3.5K, which will be just over 25 lux, so it's still within our range. Should have output, and we do. Output still high for the op amps, and we have current going out through those turned on diodes. Now, this is the last case I simulated, 4.3K, which would be under 25 lux, outside of a range we want. This one is low, basically 0, so with the min function, current will go through that diode. That will be the one that's turned on. So again, just a summary of all that. When it's between 25 and 100 lux, these diodes are turned on, and there will be current running out that direction, which is the objective. When it's between 25 lux and 100 lux, it should have current going out this spot here. Okay, so next coming up, we'll do a demonstration, and we'll be measuring the voltage at this point. Okay, so right now I have it set at, glare's hard to see it, but it's 800 ohms right now, so that's below the 1K. Therefore, it should be off. And I mean, we get close, it's 0.3 volts. But now as we move it up, go in between the 1K and 4K, we'll put it at 1.8K. And that bumps it up to 0.5 volts. And again, if we go above, that's 4.8. Read it. And again, it drops down to the 0.3 volts. Now we'll do it again, but this time I've taken out that resistance substitutor and put in the actual light sensor. So right now, just normal light. It should be on, and it is 0.5. I'll place my finger up on top of it to block some light coming in, and you can see it goes down. I'll remove my finger now, it jumps back up, put it back on. Similarly, if I add light to it, like I am, it'll be low. If I remove the light, it goes back up, bring it back, drops down. A couple notes you should be aware of. In the simulation I had 2 diodes back to back, and that's to simulate the drop across this transistor. Second note, going back to the simulation, we can see right here, 0.38, this is when it's turned on. whereas in the demonstration we had 0.5 volts. Must be something about these diodes in the simulation, because ideally it should be 0.7 when turned on. So I'm not exactly sure why that's goofy as it is. And then when it's turned off, 0.7 volts there, and we get 0.3. So it's about double what the simulation gave us. I'm not really sure about that, but I do know that as long as this, or as long as when it's off, one of those two has the lowest value, and they're all the same diodes, then it isn't in function. This will be the only diode turns on. So as long as that's the case, the circuit should mostly behave as it is, as long as it's in a range that give us the right amps. And as mentioned earlier, it is close enough. We got 480 amps according to this simulation, and demonstration is between the ideal and this, so it's between 400 and 480 microamps.